Hello students, I am Subhashish. In the previous session, we have learned the division of a polynomial by another non-zero polynomial. In this session, we shall study a simple method of finding the remainder. In the case of the divisibility of a polynomial by a linear polynomial, we use a well-known theorem called remainder theorem. Remainder theorem. If a polynomial p of x of degree greater than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is p of a, where a is any real number. Significance of remainder theorem. It enables us to find the remainder without actually following the cumbersome process of long division. Learning outcomes. After completion of this lesson, you will be able to understand how to perform polynomial division, specifically when dividing a polynomial by a linear polynomial. How to apply the remainder theorem to find remainders when dividing polynomials, reducing the need for lengthy division processes. The remainder theorem and the factor theorem can be used together to factor polynomials by identifying their linear factors. Keywords: polynomials, factors, remainder theorem, factor theorem, division, dividend. Let us see an example. Example: find the remainder when f of x is equal to x cube plus 3x square plus 3x plus 1 is divided by x plus 1. Solution: from g of x, which is equal to x plus 1, g of x is equal to 0, that is x plus 1 is equal to 0. By moving it right hand side, we get x equal to minus 1. Substitute the x value in f of x, we get f of x equal to x cube plus 3x square plus 3x plus 1. By substituting f of minus 1, which is equal to minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. After solving all the things, we get the remainder as 0. Hence, the remainder is 0. Let us see another example. Check whether f of x is equal to x cube minus x plus 1 is a multiple of g of x is equal to 2 minus 3x. Solution: from g of x is equal to 2 minus 3x. When g of x is equal to 0, then x will be equal to 2 by 3. After substituting 2 by 3 in the equation, we get 2 by 3 whole cube minus 2 by 3 plus 1. 2 cube is 8 and 3 cube is 27, minus 2 by 3 plus 1. By taking LCM, we get 8 minus 18 plus 27 by 27. After solving, we get 17 by 27, which is not equal to 0. Therefore, f of x is not a multiple of g of x. Let us see one more example. Find the remainder when f of x is equal to x cube minus ax square plus 3x minus a is divided by x minus a. Solution: let g of x is equal to x minus a, then g of x is equal to 0, that is x minus a is equal to 0, then we get x equal to a. Substitute the x value in f of x, we get f of x is equal to x cube plus ax square plus 3x minus a. Now substitute a value in place of x. We get a cube plus 3 into a square plus 3a minus a. After solving, we get a cube minus a cube plus 2a. After cancellation, we get 2a. Hence, the required remainder is 2a. Let us see another example. Without actual division, prove that f of x is equal to 2x power 4 minus 6x cube plus 3x square plus 3x minus 2 is exactly divisible by x square minus 3x plus 2. Solution. Let f of x is equal to 2x power 4 minus 6x cube plus 3x square plus 3x minus 2. G of x is equal to x square minus 3x plus 2. So, we will split the g of x into linear factors, which is equal to x square minus 2x minus x plus 2. By taking common terms, we get x into x minus 2 minus 1 into x minus 2, which is equal to x minus 2 into x minus 1. We show that f of x is exactly divisible by x minus 1 and x minus 2 using remainder theorem. Substitute x value as 1 in f of x, we get f of 1 is equal to 2 into 1 power 4 minus 6 into 1 power 3 plus 3 into 1 square plus 3 into 1 minus 2. After solving, we get 2 minus 6 plus 3 plus 3 minus 2. We get it as 0. Substitute x value as 2 in f of x, then we get f of 2 is equal to 2 into 2 power 4 minus 6 into 2 cube plus 3 into 2 square plus 3 into 2 minus 2. After solving, we get 32 minus 48 plus 12 plus 6 minus 2. Then we remain with the remainder 0. Therefore, f of x is exactly divisible by x minus 1 into x minus 2. That is, f of x is exactly divisible by x square minus 3x plus 2. If p of x is divided by x minus a with the remainder p of a is equal to 0, then x minus a is a factor of p of x. The remainder theorem leads to the factor theorem. Points to remember. The remainder theorem states that if a polynomial p of x of degree greater than or equal to 1 is divided by the linear polynomial x minus a, then the remainder is p of a, where a is any real number. This theorem allows you to find the remainder when dividing a polynomial by a linear factor without performing long division, making the process more efficient. The remainder theorem and factor theorem can be used together to factor polynomials by identifying their linear factors.